Hi Calc AB, this is page 47 in your binder. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by F, cubic feet per hour, where T is measured in hours since midnight. Janet removes snow at 6 a.m. The rate G of T in cubic feet per hour at which Janet removes snow from the driveway at time T hours after midnight is modeled by G, which is a piecewise function. Letter A, how many cubic feet of snow have accumulated on the driveway by 6 a.m.? So you have to remember which function is which, and function F represents the accumulating function, where the snow is being added up. And because snow begins to fall at midnight, that represents time 0. So part A represents the integral from 0 to 6 of f of t dt. I've put that function into y1 in my calculator, and then the calculator can help me do this integral. So this is math function integration from 0 to 6 of y1 dx. $142.2747, and even though the text says the units, it might not on our AP test, so it's just good practice to write units in your problem. It's cubic feet because the rate was given in cubic feet per hour, and we're integrating over hours. That's why our unit is cubic feet. Part B, find the rate of change of the volume of snow in the driveway at 8 a.m. So I'm going to briefly talk about the volume of snow as a function. We know that there is no snow on the ground at midnight, and then we have a function that's going to add up the snow, and then we also have a function that's going to be removing the snow. And we know that the snow is not going to be removed for all the times, but in general this is a very basic understanding of volume. The volume of snow is changing by the derivative of this function. So the derivative of 0 is 0. The derivative of the integral is just f of x, and the derivative of this integral is just g of x. So at 8 hours after midnight, which is 8 a.m., we're really just looking at f of 8 minus g of 8. So my calculator can help me with f of 8. So on my home screen, I'll do y1 of 8. So that's 48.4170. And then you subtract g of 8, and g of 8 is 108 by looking at the piecewise function. So negative 59.5830. And the units are cubic feet per hour. Part C. Find h of t, let h of t represent the total amount of snow in cubic feet that Janet has removed from the driveway at time t hours after midnight. Express h as a piecewise defined function with domain 0 to 9. So because the rate of snow removal is piecewise, the amount of snow being removed is also piecewise. So the rate for G is 0 cubic feet per hour for all of the hours between 0 and 6. So therefore, there is no snow being removed for those first 6 hours. For the next chunk of time between 6 a.m. and 7 a.m., the rate of snow removal is 125 cubic feet per hour. So that is a constant rate. And you've got to be careful with the units for this function. This function is not a rate. So you have to account for the amount of snow that's been removed in the previous piece. So there has been no snow removed in the previous piece. And then we can integrate from 6 to t of 125 dx, and that's going to work for hours between 6 a.m. and 7 a.m. So this is the same thing as 125x from 6 to t, which is 125 times t minus 6 for all hours between 6 and 7. You want to make sure that in your piecewise definition, that you don't overlap. So if you include equality here, that you don't include equality in the next piece. After that 7 a.m. mark, you've gone the full hour. So if your rate was 125 cubic feet per hour, and you've gone for 1 hour, that means you have removed 125 cubic feet of snow after the conclusion at 7 a.m. So the next piece will be 125 already removed, plus what gets removed between the hours of 7 and 9 a.m., going all the way up to 9, of 108 dx. So that 125 has to stay. So I'm doing a lot of work to show all of the pieces. I think it's a good idea to show the integral because that connects to our class, and then you can go straight to this piece if you want. But because they do say it's a piecewise defined function, it's important to make sure that you write this in pieces and that you include the domain of each of your pieces. Letter D, how many cubic feet of snow are on the driveway at 9 a.m.? So this represents a volume question, and the volume of snow is going to be equal to at 9 a.m. is going to be equal to the zero amount from the amount of snow on the ground at midnight plus the integral from 0 to 9 of f of t dt, which represents how much snow is accumulating. And then we have to take away h of 9 because that represents how much snow is being removed. And remember that h was sort of complicated because the rate at which snow was being removed was piecewise. Therefore, the amount being removed is also piecewise. So the integral from 0 to 9 is a number we can get on our calculator. So 367.3346 minus h of 9. H of 9 represents this piece, using this piece, I should say, in our h function. So we're going to subtract 125 plus 108 times 9 minus 7, because it's 2 hours after 7 a.m. where you're removing snow at that rate. So 367.3346 minus 125 minus 216. Is 26.3346 cubic feet of snow. And that's it for page 47.